Hi, I'm Tu Suyuan from Fudan University. Today I would like to share our recent work which has been accepted by CVPR 2025. Current diffusion models for human image animation struggle to ensure the identity and consistency. This paper presents the StableAnimator, the first end-to-end ID-preserving video diffusion framework which synthesizes the high-quality video without any post-processing, conditioned on a reference image and a sequence of poses. Our motivation is that when dealing with the pose sequences that exhibit significant motion variation, current approaches suffer from significant distortions and inconsistencies, particularly in facial regions, distorting the identity information. To address this issue, there are a number of approaches exploring the identity preservation for image generation. Yet limited effort has been made for videos. While one could add temporal modeling layers to image diffusion models, doing so will inevitably affect the original spatial parallels. As image domain ID preserving methods rely on stable spatial parallels, the interference caused by the temporal layers leads to unsatisfactory results. Yet for image animation, how to preserve the identity information while ensuring the video fidelity is extremely challenging. Furthermore, recent animation models rely on face fusion for post-processing, which also degrades the quality of the animated video, particularly for facial areas. In light of this, we propose the StableAnimator consistently of dedicated modules for both the training and the inference to maintain the ID consistency for high-quality human image animation. First, we proposed a global content-aware face encoder and a novel distribution-aware ID adapter to enable the video diffusion model to incorporate the face embeddings without compromising video fidelity. Second, we propose a novel HJB equation-based face optimization method that further enhances the face quality while conducting conventional denoising. It is only active in the interference without training any diffusion components. To our knowledge, we are the first to explore the video diffusion for end-to-end ID-preserving human image animation. Third, experimental results on benchmark datasets show the superiority of our model over the SOTA. Regarding the distribution-aware ID adapter, the outputs of the face encoder are then fed to our ID adapter for further alignment to avoid the distortion of the spatial features occurring when directly incorporating the image domain ID preserving methods into the video diffusion model. The future distortion describes the misalignment between the face embeddings and the spatial diffusion patterns caused by the diffusion shift when temporal layers are added at each denoising step. The distribution-aware ID adapter modifies each spatial layer of the unit. Before each temporal modeling, our ID adapter aligns the refined face embeddings with diffusion pattern based on their future distributions, effectively avoiding the future distortion. In particular, diffusion patterns perform separate cross-attention with the refined face and the image embedding respectively, with their means and variance computed. We then use the respective means and variance to conduct the alignment between the resulting results. This alignment effectively mitigates the interference from the temporal layers by progressively bringing two distributions closer at each step, ensuring the ID consistency without compromising the video fidelity. During inference, to further enhance the face quality and reduce the reliance on post-processing tools, StableAnimator throws the Hamilton-Jacob-Bellman equation for face optimization. We find that throwing the HJB equations corresponds with the core principles of the diffusion denoising. Therefore, we incorporate the HJB equation into the inference processes, which allows a controllable variable to guide and constrain the direction of the denoising process. In particular, the solution of the HJB is used to update the latent for each denoising step, constraining the denoising path and directing the model towards the optimal ID consistency. Since these procedures always adapt to the current distribution of the denoised atoms, the simultaneous denoising and the phase optimization effectively eliminates the detail distortions, so it can replace the previous over-reliance on third-party post-processing tools, such as the phase swapping tools. And this is the quantitative comparison between our StableAnimator and the current human image animation models. We can observe that ours outperforms all the competitors. There are the animation results generated by StableAnimator. And we also can see that our model is capable of animating multiple individuals. There are the qualitative comparison results between our StableAnimator and the current human image animation models. We can see that our model achieves the best performance. In terms of the ablation studies, we can see that removing the core components significantly degrades the performance, particularly in phase-related regions, highlighting that our components significantly enhance both video fidelity and the single frame quality while preserving the high ID consistency. That's it. Thank you.